Yeah, good afternoon, everyone, and welcome to the afternoon session. Over to you, Sindhu.
Thank you, ma'am. A very good afternoon to one and all present here. I am Sundar Shastri, and today I have the honor of introducing our renowned resource person, Dr. Vanishri Arun, ma'am. Dr. Vanishri Arun is currently working as an assistant professor in the Department of Information Science and Engineering at Sri Jayachamarajendra College of Engineering, a constituent college of JSS Science and Technology University, Mysore, Karnataka. She has a teaching experience of 16 years at technical institutes and industrial experience of 8 years. Her research interests include biomedical informatics using data mining and machine learning techniques, artificial intelligence, statistical method in information processing, and teaching learning processes. She has pursued a Bachelor of Engineering in Computer Science and Engineering, MTech in Software Engineering, and PhD in Biomedical Informatics from Sri Jayachamarajendra College of Engineering. She has two patents to her credit titled Inter-USB Data Transfer Device and a device for self-recognition of veins and insertion of intravenous cannula procedure. She has delivered lectures in various AICTE sponsored faculty development programs and other institutions and universities. She was recently selected as a mentor and evaluator of Toykathon 2021 by the Innovation Cell of Ministry of Education, Government of India. Dr. Vanishri Arun ma'am has published over 20 research papers in international and national conferences and journals. Today, the National Research Foundation is expanding research efforts in the technology. In the context of machine learning, the National Research Foundation is considering a three-pronged approach, starting with advanced AI research, developing and deploying application-based research, and advancing international research efforts to address global challenges in areas such as healthcare, agriculture, and climate change using AI. Universities are now aiming to offer PhD and master programs in core areas such as machine learning and professional areas like healthcare, agriculture, and law. Hence, the topic of today's session will be machine learning, a teaching learning assessment endeavor. I now hand over the floor to Dr. Vanishri Arun ma'am. Thank you.
Thank you for the introduction, Sindhu. So let me start my presentation. Good afternoon, everyone, once again. Hope my screen is visible.
Yes, ma'am, visible. Yes.
Thank you so much. Good afternoon once again. So our FTP topic itself is on teaching, learning, and assessment practices, and I would be we shall be discussing about machine learning, how machine learning should be taught in technical institutes. So before that, let me start with a brief introduction on the NEP. All the eminent speakers have already spoken a lot about teaching, learning, and assessment practices, and also the new education, the national education policy. So the national education policy has acknowledged the importance of artificial intelligence and AI education in today's time. So to align India's curriculum to the 21st century and to prepare the students for the AI economy, the policy lays profound emphasis on the need to impart the necessary technical knowledge at all levels of education. So students will be exposed to crucial skills such as digital literacy, say coding, computational thinking. So right from the young age, they'll be exposed to such skills through the teaching of contemporary subjects such as artificial intelligence. So one of the contemporary subjects is artificial intelligence. Another could be design thinking. Further, topics such as, say, 3D machining, big data analysis, machine learning, all these will be integrated with the undergraduate education to train industry ready professionals. That's very important when students join to technical institutions. Their focus or their vision will be industries. So the goal will be industries. They want to complete the engineering course so that they are industry ready. So, to make them industry ready professionals, such contemporary subjects are added in the curriculum. As I mentioned, few of them like artificial intelligence, design thinking, 3D machining, big data analysis, machine learning, data mining, and so on. So, all universities will offer, according to the new education policy, all universities will have to offer doctoral and master's programs in core areas such as machine learning. So, in addition, colleges may also offer a targeted training in low enterprise tasks for supporting the AI value chain, such as data annotation, image classification, speech transcription, and so on. So, the education embedding these facilities, the education embedding these topics or these programs which I mentioned, these will facilitate the youngsters to meet the requirements of the current world, right? The current world, in the sense, it could be communication, creativity, problem solving, and so on. That's more essential in the current world. So, further, to make India a leading knowledge hub of disruptive technologies, the National Research Foundation will promote high quality research in the realm of science and technology. So, given the rising applicability and falling costs of AI based predictions, special focus has been given to promoting research in this domain, and a three pronged approach we call. So it's all based on the national education policy. So they mention about this three pronged approach, and this three pronged approach has been laid out to channel the research in artificial intelligence. So those three pronged approaches are, say, advancing core AI research, developing and deploying application based research, and establishing international research efforts to address global challenges in areas such as healthcare, agriculture, climate change, using artificial intelligence. So, this policy also envisions the use of artificial intelligence powered solutions for the attainment of its goal of a multilingual as well as holistic education. Um, and the efforts of promoting multilingualism among students, right? Introducing many languages, or say delivery of lectures in many languages or their regional language or vernacular languages. So this effort of promoting multilingualism among students will be interlocked with efforts to enhance national language processing capabilities for our India's diverse languages and vernacular languages, as we say. So that's one of the important initiatives of the government of India. So in line with the national vision of digital India, the policy has highlighted the symbiotic relationship between technology and education. The transformational journey of India will be catalyzed through technological education and research, as provided in the national education policy. And also, advanced tech driven solutions will transform the educational processes. And what's important here is a workforce, right? So what's important is a workforce that has been trained in AI. So when you say teaching, we need a strong workforce which can train the students or which can teach the students, or anybody for that matter who's learning. So we need a workforce that has been trained in artificial intelligence and related technologies. So training in artificial intelligence and related technologies must start early for students, right? to later become the workforce that is able to successfully create or invent and improvise. So this workforce should train students, and those students should later become the workforce. So this NEP policy also aims to use education as a means to sensitize students, right, to the issues and ethics surrounding artificial intelligence. And during the recent past, artificial intelligence has become ubiquitous. All of us know that artificial intelligence has become ubiquitous and has made inroads in all walks of life, including education. So, with this background about the national education policy and the teaching learning assessment, let's understand how machine learning should be taught. So, I just narrow down my discussion to machine learning. Let's understand how machine learning should be taught in engineering courses, especially in computer science and information technology related courses. So, in order to answer the fundamental questions and acquire useful insights, useful insight in the performance and behavior of machine learning, it's important to enhance our understanding of machine learning, right? So I understand all of you are professors in various technical institutions, and you've been most of you have been teaching computer science related courses. So you would have taught machine learning, so you might not need this introduction. But for those as a preamble, and for those who need some introduction on machine learning, I would just like to give a brief uh, introduction on machine learning. So, machine learning is an application of artificial intelligence, right? It is a subset of artificial intelligence, we can say. So, subsets under artificial intelligence are machine learning, deep learning, and so on. So, this machine learning, which is an application of artificial intelligence, allows users to feed data to a computer algorithm and have the computer analyze and make data driven recommendations and decisions, right? So, it allows users to feed in data into the algorithm, and it will have the computer analyze and make data driven recommendations and decisions. So let's check why do we actually need machine learning, right? Why do we need artificial intelligence? Why do we need all of us know where we know the applications of machine learning. Even a small child knows the application of artificial intelligence, or they might not know about machine learning, but they would definitely know about artificial intelligence. So why do we actually need machine learning? So it's needed for the tasks that are too complex for humans to code directly. So what do you mean? The tasks which are complex for humans to code directly. So some tasks are so complex that they are impractical, right? They might not be impossible, but they might be impractical for humans to work out work out all of the nuances and code for them explicitly, right? So instead, we provide a large amount of data to a machine learning algorithm and let the algorithm work it out by exploring that data and search for a model that will achieve what the programmers have set it out to achieve. So what essentially we're doing here is we provide large amount of data to a machine learning algorithm, right? And the algorithm explores the data. It is programmed in such a way that the algorithm explores the data and searches for a model. A model is developed, and this algorithm searches for a perfect model that will achieve what the programmer wants the outcome to be, right? So, some of the applications to mention are some of the applications that are too complex to code. I said IMI machine learning is used where it is where the applications developed are complex for humans to code. So, which are these applications which are complex? So, it could be speech recognition, right? So examples under speech recognition could be home automation, virtual assistant, automobiles, robotics, and so on. Many more. We have many more like this. right? And under text analytics, we have sentiment analysis, entity recognition, text categorization, word prediction, and under computer vision, we have healthcare, object detection, face recognition, and many more. You might be knowing many other applications apart from these. So to mention few, I've just mentioned some of them here. So in these areas, applications are complex to code. So coding is very complex, and decision making is complex, since we generate the generation of data is so exuberant in the current world that it's very difficult for humans to handle them. So we need the help of some system which can handle the data generated, massive data generated, and to work on it, to understand the data, to develop a prediction system or recommendation system. In all these, we seek the help of machine learning or artificial intelligence, right? So, some of the machine learning related fields are mentioned here. Say it could be data mining and knowledge discovery in databases, pattern recognition, statistics. So, to mention a few, these are machine learning related fields. And yeah. So these are some applications of machine learning. So I have just taken some of them from the internet. So ELP is an American public company that develops, hosts, and markets the elp.com website. And the ELP mobile, it also markets the ELP mobile app, uh, which publishes crowdsourced reviews, right? It publishes crowdsourced reviews about businesses. You can see here, it is, uh, if you have a close watch of this picture, of this image, you can see if the first picture says inside the restaurant, second one says love records on the walls, the third one says Friday night, the fourth one says the interior. So what it does is it publishes the crowdsourced reviews, okay, about businesses, right? And it also classifies, it's also used to classify, it uses machine learning. This application, ELP application, uses machine learning to classify images into interior and exterior categories. So you can see that it's categorized. The images are categorized as inside, right, walls, night, right? Oh, Friday night, which is interior, the interior, seating inside, the interior view. So it uses machine learning to classify the interior and exterior categories also. Yeah. So another application is Pinterest. Pinterest. Yeah. Again, this is used by many of them. So this Pinterest is again an American image sharing and social media service. It's designed to enable saving and discovery of information on the World Wide Web, right? Using images, and on a smaller scale, GIFs and videos also are saved and they are discovered in the form of pinboards. You can see in the picture here. Right? They use machine learning again for improved content discovery. Okay, so Pinterest uses machine learning for improved content discovery. And another application is Facebook. All of us are familiar with Facebook. Like on social media itself, we generate, I do not have the number with me, but we generate humongous amount of data, isn't it? So this is one of them. Facebook also generates a lot of data per minute, per second, per minute, hour, and so on. So Facebook also uses machine learning for chatbot army, right? The chatbot, you can explore, you can, I don't want to go deep into this, so you can explore about chatbot army on the net for more information, right? So this is one of the applications. And interesting, yeah, this is one of the interesting applications of machine learning, where Google is working on neural networks and machines that dream, right? So we've always heard of people dreaming, humans dreaming. So they're working on neural networks and machines that dream. So Deep Dream is one of them. Deep Dream is a computer vision program created by Google engineer by name Alexander Maud. Okay, so Alexander Modwin or something like that. So this Deep Dream uses convolutional neural network to find and enhance patterns in images, creating a dream-like hallucinogenic appearance. Okay, even like hallucinogenic appearance in the sense it creates images, it creates some patterns, um, it finds and enhances the patterns in a particular image, and it creates a dream-like appearance, okay, in the deliberately over-processed images. It's an interesting topic. You can explore on this, right? So, as our topic is not this, the present topic is about teaching, learning, and assessment. Let's not go deep into this. So, another application is about IBM Watson Health, which was created to help solve some of the world's most pressing health challenges through data analytics and artificial intelligence, right? And fine. So these are some of the applications of machine learning, and there are many more applications. To just introduce few of them, I've included these applications, which are interesting, right? So my machine learning is categorized as, all of you know, supervised learning, unsupervised learning, and reinforcement learning. You can see the sub categories of each one, right? Supervised, under supervised learning, we have regression, classification. Under unsupervised learning, we have dimensionality reduction, clustering, and reinforcement learning. Where yeah, let's discuss slightly about that too. So supervised learning is the machine learning task of learning a function that maps an input to an output, right, based on example input output pairs. It Machine learning learns a function that maps an input to an output, right? So here training data for supervised learning includes a set of examples with paired input subjects and desired output. Yeah. So a supervised learning algorithm analyzes the training data, produces an inferred function which can be used for mapping new examples. So classification is the problem of identifying to which of the to which of a set of categories a new observation belongs, right? On the basis of a training set of data containing observations whose category membership is known, right? So that is classification. So some of the classification techniques are linear classifier. Under linear classifier, we have a support vector machine, right? We have logistic regression. Under parametric or probabilistic functions, we have Naive, hidden Markov models. Under non-parametric or instance-based functions, we have k-nearest neighbor, right? And under non-metric or symbolic functions, we have classification and regression tree, which is termed as SCART, and decision tree. And under aggregation, we have AdaBoost, random forest, and under artificial neural network, we have SGD classifier, right? So again, under another supervised learning, we have clustering. So clustering is a machine learning technique that involves the grouping of data points given a set of data points, right? It involves grouping of data points, and we can use a clustering algorithm to categorize each data point into a specific group, right? So in theory, data points that are in same group should have similar properties and similar features and or similar features, while data points in different groups should have highly dissimilar properties and features, right? So, in reinforcement learning, algorithms get to choose an action in an environment, right? It gets to the algorithms get to choose an action in an environment, and then are rewarded either positively or negatively. They are then rewarded for choosing this action. Okay, so the algorithm then adjusts itself and modifies its strategy in order to accomplish some goal, which is usually to get more rewards. Yeah, and this type of machine learning is very popular in artificial intelligence assisted gameplay as agents, right? So usually it's used in as we saw in this. Yeah, we can see here the applications of reinforcement learning are in game AI, skill acquisition, learning tasks, robot navigation, real-time decisions. Okay, so here this reinforcement learning is very popular in AI-assisted gameplay, as agents are allowed to explore a virtual world, okay, and collect rewards, and then the best navigation, and they learn the best navigation techniques. Okay, and so this model is very popular in robotics, especially in the field of self-automated machinery, including cars. Right, you must have heard of self-automated cars. Uh, so I just wanted to introduce these three concepts of machine learning. So after learning, machine learning is a vast topic, and you can explore based on your interest. You can explore on machine learning, right? So with this background of machine learning, let's now understand the best teaching, learning, and assessment practices in machine learning based on national education policy. So far, we've heard many eminent speakers speak about teaching, learning, and assessment. It's common. So it is common. It applies to all the subjects. Even NEP applies to all the subjects. It's general, and even teaching, learning, assessments are general. Just the previous during the previous session by Dr. Rajendra Singh, we understood how subjects have to be taught based on, say, it could be OBE or Bloom's taxonomy, or based on the education policy, and how students have to learn and how assessment has to be done. But again, let me narrow it down to machine learning. So let us consider the subject, consider machine learning as a subject, and how we need to teach, learn, and assess this particular subject. Okay. So according to NEP, there is a need for flexibility to students. So it is student centric, rather learner centric. Right? According to NEP, education is learner centric rather than teacher centric. So, so yeah, NEP has given a rare glimpse in what can be achieved through the transformation of education. So the new NEP clearly states that it is time to take on a policy that is undoubtedly student centric, right? So we teachers have to remember that what we teach is in favor of what we do in our institute, should be in favor of students. So it clearly mentions that it's time to take on a policy that is undoubtedly student centric, or what can be safely put down as education 4.0, right? That's termed as education 4.0. So the time has indeed come to recognize the fact that the student is the main stakeholder, right? The main stakeholder in education system is the student. So when we say it is student centric, then the main stakeholder is the student. And we also need to understand that efforts must be taken to make the system respond to their dreams, right? Dreams and their aspirations. So, in this line of thinking, the new policy gives the acceptability of many modes of learning, including that of face to face learning, online learning, distance or virtual mode. So it also promotes use of, say, occasional courses, multidisciplinary courses, multimodal approaches, thereby focusing on blended teaching learning. So that is, it focuses on blended teaching learning, all learning, where it allows or it accepts many modes of learning. Okay, many modes like face to face or online or distance or virtual, clear, or we can even promote occasional courses, multidisciplinary courses, multimodal approaches. So this focus, so this there is a focus on blended teaching learning in the national education policy. Fine. So, the student centricity means, what do we mean by the student centricity? How much should that be? So, this student centricity means that availability of multiple entry and exit points, right? The multiple entry and exit points must be available when we say it is student centric, or say promotion of mother tongue. We have our country is a multilingual country, and we have vernacular, we have regional languages, vernacular languages. We have many languages in our country. When you go from one place to another, from Mysore to Bangalore, you can see a different kind of Kannada spoken, right? So when we have such a system, there is a promotion of the mother tongue and other languages also, and focus on arts and humanities. Even that is very important. That is also encouraged in NEP. Focus on arts and humanities, and reformation of examination systems with open book testing, group exams, right, and so on. And the ready support for mature learners, and above all, the concepts of academic bank of credit, right? This concept that factors in the potential of time, place, mode, speed, language, right? Which in many ways are going to be the new approach of education. So, in the realm of educational transformation, this academic bank of credit gives sufficient elbow room for many things, especially keeping in mind such areas as, say, flexibility, quality, interests and needs, student centricity, right? The real worlds of study, and also the real worlds of study, and taking up examinations when ready, right? It's not that you fix up dates for examination. Examinations are given, or students take up the examination when they are ready. Okay, they study the real worlds. So all these we have the new education system has to give sufficient room for all these things. In other words, the students have to be given the chance to pick teachers and timings. Yeah, what it means is that students are given chance to pick teachers, their teachers, and also their convenient timings. Framing their own courses, they're allowed to frame their own courses, and they're allowed to design the degrees. Okay, or they're allowed to study through any mode, and with learning and examinations literally on demand at will. Okay, based on their convenient time and their will, they can take exams and select any of these. This yeah, this figure presents the idea. You can check this, right? The whole idea is shown in this figure here. And technology is a critical element in the whole process, right? So the academic bank of credit, what I mentioned, as currently being evolved, understands that the new teaching, learning, and educational processes of this NEP policy will have to be backed by adequate technologies. We need adequate technology also. When you're given flexibility and quality, needs and interest, studies, student centricity, real world, exams when ready, when all these options are given, okay, then we need to have the system or the policy will have to be backed by adequate technologies and blended modes of acquiring knowledge, right? Just like that, students cannot opt for any of these. He has to be given all the facilities, right? So there are variety of tools available. So in this during this pandemic, we've learned to use the various modes available very effectively. We've been using even now we are using the technology to for the conduction of this FTP, right? So there are variety of tools available that can help make teaching more effective. So board is one of the most capable teaching tools in space. I am very comfortable with board teaching, blackboard or whiteboard, right? So in board teaching, there is more involvement. I feel there is more involvement and more depth in the subject because we can just show it to them, chalk it down on the board, whatever is necessary to express, right? The concept explanation is easy with blackboard teaching, and PowerPoint presentation is also effective. It's useful for students to make notes so that it remains on the screen for some time, or we can share it with them. And regular and surprise quizzes. So quiz provides a good lead in for either a lecture or discussion of the material. Students tend to actually read the material, isn't it? So, quality assignments. So, the quality of assignments is a construct that has no absolute definition. How do you how do you check the quality of assignment? So, it has no definite definition. Therefore, given protocol provides a conceptual lens through which quality is defined. Okay, for this, we can adopt the framework of authentic intellectual work, right? Authentic intellectual work is viewed as relatively complex and socially, or but they are socially and personally very meaningful. And according to Newman, there are many people who have worked in this area. So Newman, in a paper which I read, authored by Newman et al., describe authentic intellectual work as having three distinctive characteristics. Okay, so firstly, it involves the construction of knowledge. Okay, arguing that authentic work requires one to go beyond routine use of information, and also uh, going beyond the skills previously learned, right? And problem solvers must construct knowledge that involves organizing, say, interpreting, evaluating, or synthesizing prior knowledge to solve new problems. Okay, so this quality depends on these questions, whether it is actually addressing these. And the second characteristic of the authentic intellectual work is disciplined inquiry, so which involves the use of prior knowledge in a field, in-depth understanding, and elaborated communication. Right? Hope you get my point. And the final characterizing feature is value beyond school. Okay, the idea that uh, the people do authentically, or the work what people do authentically is intended to impact or influence others, right? So that's the final characterizing feature. And having good quality questions in exam papers is very important to ensure that the intended knowledge, understanding, and skills are assessed, right? So it is essential to include questions of three levels of complexities. So whenever generally when we frame or prepare a question paper, we have to remember that we need to include questions of three levels of complexities, namely simple, moderate, and complex. Okay. And take home or an open book. Yeah, the next one is take home or open book. I've mentioned here one of the teaching as one of the teaching methods. So take home or an open book work is an assessment method, which is designed to allow students to refer to either class notes and summaries or a memory aid, say, or textbooks or any other approved material. Well, when they want to answer any questions, they can make use of any materials, okay, under some controlled conditions. So this may test more than just rote learning. What we say, rote learning. This is memorize and put it out when they write exams. So this open book work or take home assessment methods will test more than just rote learning, their creativity. It shows their creativity. It shows how well they conceive or how they understand the concepts. Right? It tests the student's ability to quickly find relevant information and then to understand, analyze, apply knowledge. Right, while thinking critically, critical thinking, yeah, as one of the speakers mentioned, that's the need of the hour, critical thinking. Right, and also how they locate. What's important is how they locate, how they apply, and how they use information. That's very important, rather than just rote learning, what we call. Right, and the next method is quality mini projects or implementation. So a mini project is an assignment, again, that you try to complete at the end of the semester, right? And it's given to just strengthen the understanding of fundamentals through effective application of theoretical concepts. So, mini project or implementation of machine learning techniques and approaches. When I come to machine learning, so implementation of these machine learning approaches or techniques can help students to boost skills, and also it might help them to widen their horizon of thinking. Right? So, how should we learn? How should the machine learning be planned? So before we teach, we have to plan how we should teach, how we should frame the curriculum, right? How to frame the course or curriculum or subject. So machine learning subject should be planned by setting and defining appropriate learning outcomes. Hope all of you are familiar with these learning outcomes, course outcomes, right? Um, course objectives, all these. So the machine learning subject should be planned by setting and defining appropriate learning outcomes for lectures, assignments, and assessments, considering student development. Okay. So once planned, how should machine learning be taught? Right? Fine. So the learning goals should transition from task-specific skills to combining learned skills to build a machine learning model. So when you say machine learning, it's not just acquiring data or understanding data or presenting it to an algorithm. No. So it should, the learning goals should transition from task specific skills to build a machine learning model, and finally applying skills to solve a problem which essentially solves societal issues. So students should be taught to aim at solving societal issues, right? That's the reason we are working on all these different technologies, right? By eventually we want to solve a problem or solve a societal issue. So we need to set the learning goal to apply skills to solve societal problems, and dwell on concepts means talk about concepts, or rather discuss about the concepts. Okay, rather than just superficially touching upon it, discuss about the concepts. And control content tyranny. So professors need to relax their authority. Okay, they also need to pull back from trying to cover assigned material. So it's not that once you framed the syllabus, it's not that you have to stick on to that. Okay, you have to pull back from trying to cover the assigned material, and you have to relax your authority also. The goal is not for the professor or teacher to cover the subject here, but for the students to learn it. If he learns a part of it, that's fine. Yeah, you don't have to impose the rest on him. Or if he wants to learn more, you covered the whole syllabus, and the students are interested to learn more, so you add on more. So the professors should relax. Okay, they need to pull back from covering the assigned material. Yeah. So the type of data that you're working with is a very large piece of machine learning. Okay. So next is let me move on to teaching machine learning, and I mentioned about general how it should be planned and how it should be taught generally. So let me come to teaching machine learning. So the type of data that you are working with is a very large piece of machine learning. As said, data plays an important role here, and you know about data. And as I mentioned, we've been generating humongous amount of data in our day-to-day life, right? So it must precede most of the analysis, because the type of data we have impacts the type of analysis that is even possible, right? So whenever we are faced with a new data set, the first three questions we should ask about it are these. Okay, which are they? Oh, let me tell you. Whenever you get a new data set, you have to ask three questions. You need to ask yourself or ask about the data on these three questions. First is the data organized or unorganized? Okay, you need to work a lot on data first. So when I mention, I always tell my students to work on data first, understand the data first. Okay, then you can decide what you can do with the data set. So, firstly, you need to ask a question: is the data organized or unorganized? For example, does our data exist in a nice, clean row or column structure? That's what we mean to say when we say it's organized data, right? And next is each column quantitative or qualitative? Right? For example, are the values numbers, strings, or do they represent any quantities? Yeah. And the next question is, at what level of data is each column? So there are many levels of data. For example, uh, the values could be at a nominal level, ordinal level, interval level, or ratio level. So the answers to these questions will not only impact the knowledge of the data at the end, but will also dictate the next steps of the analysis. Yeah. So they'll dictate the type of, say, graphs we are able to use, or how we interpret them in our upcoming data models. And sometimes we'll have to convert from one level to another in order to gain a more perspective about it, right? And some other questions like the measures of center we can use, the measures of variation we can use. All these questions you have to ask when you acquire data. Clear? So it is a common misconception that only those with a PhD, or those who are research scholars, those who are researching or postdoctoral, whatever, or geniuses. Let me say, it's a common misconception that only geniuses can understand the math and programming behind machine learning. No, this is absolutely false. So understanding machine learning begins with three basic areas. If you've taught machine learning, all of you would be knowing. Or even for general programming, general understanding of, say, application, You need to have good mathematics background. You need to have good domain knowledge, programming and solving, practical programming expertise. So when we say math or statistics, essentially, this is the use of equations and say formulae to perform analysis. Right? Basically, it's used to perform analysis. And machine learning requires a thorough knowledge of mathematical concepts like linear algebra, statistics, probability, and so on. Mathematics is an essential concept. Even the first session was on mathematics. So professor explained very well. He took us from the basics by comparing, say, naturally available fruits and vegetables to human body, and how mathematics started from the mythology to the current world till the AI. The journey of this transition was very well explained by him, right? So mathematics is an essential concept. So we use vectors, we use vectorization, we use regression techniques like linear regression, logistic regression, decision trees, Bayesian networks, shallow networks, deep networks, and so on. And learning algorithms, backpropagation, delta learning, activation function, convolution layers, partial differentiation, Jacobian, Hessian, loss and cost functions, underfitting, overfitting, regularizations, all these are mathematics, right? All these are mathematics. So mathematics is an essential concept in machine learning. And next, domain knowledge. This refers to understanding the problem domain. Say you're working in the area of medicine. I work on biomedical informatics, and I need to have a good domain knowledge about medicine, right? About the disease I'm working on. So without that, it's futile working on using any machine learning technique. So we need to have domain knowledge. It could be medicine, finance, social science, or anything. So, and next basic area is the computer programming. And yeah, usually computer engineers or computer science students or information technology students will have the ability to use code, right, to create outcomes on the computer. So, this is about the programming knowledge they have. So, that is one of the basic areas of machine learning, right? So again, in machine learning, we have 5 essential steps which we need to follow. Again, you have understood the data, you have mathematical knowledge, you have domain knowledge, you have programming knowledge, and next what? Next, you have to follow these 5 essential steps in machine learning. Firstly, when you start with machine learning, ask ask an interesting question. So, firstly, students should be asked to write down questions, regardless of whether or not they think the data to answer these questions even exists. They have to write an interesting question. They have to write down the questions. Okay, what they can do, what they want to do, what they want to achieve, what outcomes they want. Clear? And next step is obtaining the data. Obtain a collection of data. So the data can come from a variety of sources, isn't it? So maybe through simulation or say algorithm designing or through experimentation or through public domains like UCI machine learning repository, Kaggle. So wherever or live data collection, it could be live data collection. It could be, it may be through, the data collection may be through any of these variety of sources. So firstly, the second step is to obtain data. Firstly, you write a question about what work you want to do, what kind of data you want to use, what kind of outcome you want, in which area you want to work, all those. And next step is obtaining the data, right? And third step is exploring the data. Explore the data by asking again basic questions like, is the data organized? Whether the data is organized or not, or what does each row represent, what does each column represent, and are there any missing points or missing data points? Do we have to perform any transformations of the columns? right? When we have normalization is one of the important pre-processing steps, right? The where we have to transform to normalize the data set. We need to transform certain columns if they are in say categorical form. We have to convert them into numerical. It might need that way, or you might transform string data into numerical data or categorical data, something like that. Okay, so those we have to understand. So explore the data is the third step, and the fourth step is model the data. So here the step involves the use of here comes the mathematics where we use the statistical and machine learning models. Okay, in this step we are not only fitting and choosing models, but we are implanting mathematical validation metrics in order to quantify the models and their effectiveness, right? So what does it mean? We are quantifying the models and the effectiveness. So we are finding how the model works, and we are finding the performance of it, how the model is performing, right? Using various metrics, validation metrics, mathematical validation metrics we use to quantify the effectiveness of the model. Okay. So once these are done, firstly we ask an interesting question, obtain data, explore the data, model the data, and last comes communication and visualization of results. So communicate and visualize the results using plots, charts, graphs. Yeah, communication of results is as important as the results themselves. They're very important. It's very important to communicate when you have the results, and when you cannot communicate to others about your work, there's no use. Even visualization, you have visualization gives a clear idea about the results, right? So communication can be verbal or visual. Yeah, all of us have passed the stage of communicating, so all of us know how to communicate, how to present it, how to visualize all these. So these are the 5 essential steps in machine learning which we have to teach students. Yeah, as soon as they get data, they shouldn't pounce on developing a model, or trying out the data set on some algorithm. There are certain steps to be followed, and they have to follow these to make the machine learning model perform well. Yeah. So how does machine learning work? They work like each flavor of machine learning, and each individual model works in different ways. Okay, exploiting different parts of mathematics and data science. However, in general, machine learning works by taking in data, right? It finds relationships within the data, and it gives what the model has, it gives as output what the model has learned, isn't it? That's how it works. So the working of machine learning is illustrated in this diagram. So it takes data, right? By it takes in data, it finds a relationship, it learns the relationship, right? The model learns the relationship, it identifies signals, and it gives the output based on what the model has learned. Yeah? Now, how does statistical modeling fit into all of this? Right. So up till until now, I've been using the term machine learning. But you may ask how statistical modeling plays a role in all of this. So this is still a debated topic in the field of data science. Okay, I believe that statistical modeling is another term for machine learning models that heavily relies on using mathematical rules. Say it could be borrowed from probability or statistics to create relationships between data variables, often in a predictive sense, right? Excuse me. So let's explore our first true machine learning model here, linear regression. Linear regressions are a form of regression, which means that it's a machine learning model that attempts to find a relationship between predictors and a response variable. right? Predictors are x1, x2, what you see here, y equals, the equation is given, x1, x2 to xn are predictors and the response variable is y. So we attempt to find a relationship between predictors and a response variable, and that response variable is continuous here. Okay, so this notion is synonymous with making a line of best fit, right? So in the case of linear regression, we'll attempt to find a linear relationship between our predictors and our response variable. Okay, formally, we wish to solve for a formula of this format which is given here, y equals beta 0 plus beta 1 into x1 and so on, where y is our response variable, xi is our ith variable, and b naught is the beta is the intercept. B naught is the intercept and bi is the coefficient of the xi term, right? So there are three, coming to regression metrics, there are three main metrics when using regression machine learning models. They are the mean absolute error, the mean squared error, and the root mean squared error. Each metric attempts to describe and quantify the effectiveness of a regression model by comparing a list of predictions to a list of correct answers. Right? Each of the mentioned metrics is slightly different from the rest. Again, you can explore on this. Each one will tell us a different story, isn't it? Fine. Finally, the logistic regression uh, under classification model. Okay. So, training the line to fit, training the line to fit to x and y, and then asking it to predict x again. How is it? You've trained the line to fit to x, x, and y, and then you ask it to predict x again. There's actually a huge mistake in machine learning because it leads to overfitting. So, overfitting, which means that our model is merely memorizing the data and regurgitating it back to us, right? Imagine that you're a student and you walk into the first day of the class and teacher says that the final exam is very difficult in this class. In order to prepare you, she gives you a practice test after practice test after practice, many practice tests. The day of the final exam arrives and you are shocked to find that every question on the exam is exactly the same as in the practice test, right? Luckily, you did them so many times that you remember the answer and you get 100% in the exam. The same thing applies here, more or less. By fitting and predicting on the same data, the model is memorizing the data and it's getting better, right? So, so we need to combat. Yeah, again, I'll tell you how it's possible. And I was telling about logistic regression. I didn't mention much about it. So, a classification model is called logistic regression. It's a generalization of linear regression, a linear regression model, and it's adapted to fit classification problems. Okay. So in linear regression, we use a set of, say, quantitative feature variables to predict a continuous response variable. Whereas in logistic regression, we use a set of quantitative feature variables to predict probabilities of class membership. Okay? And these probabilities can then be mapped to class labels, thus predicting a class for each observation. It's just a simple classification problem if you consider a binary classification, yes or no, whether a person is diabetic or not, based on the predictors, say his age, his gender, his blood sugar level, or his blood pressure level, or his BMI. So a great way, yeah, I mentioned about this overfitting problem, and a great way to combat this overfitting problem is to use train test approach to fit machine learning models. Okay, and it works as illustrated here. So essentially, we take these steps which are mentioned. Firstly, split up the data set into two parts: a training and a test set, training set and a test set. Then fit a model on the training set and then test it on the testing set. Just like in school, where the teacher would teach from one set of notes and then test us on different questions, right? Mathematics especially. when we were in school, teacher used to give us a set of questions. We used to solve those questions in class, but in the exam we used to get a different set of questions. Right? It's in a similar way. So once our model is good enough based on our metrics, so we turn our model's attention towards the entire data set. Okay. So firstly, we split them up and then work. And finally, when the model is good enough based on the metrics, we compute using some metrics, its performance. And based on it, we turn the model's attention towards the entire data set. And now a model awaits for new data previously unseen by anyone. Okay, it makes predictions on new data. So the goal here is to minimize the out of sample errors of a model, right? Which are the errors a model has on data that it has never seen before. So this is very important because the main idea of a supervised modeling or supervised model is to predict unseen test cases. And if a model is unable to generalize from our training data and use that to predict unseen cases, then a model is not good, isn't it? So our next goal is to see and apply concepts learned so far. Right? We have understood how it has to be done. Right? Next is our next goal is to see and apply concepts learned so far in order to construct and use modern learning algorithms in order to glean insights and make predictions on real data sets. Yeah. So Naive-Bayes classification is a machine learning model which relies on Bayes theorem. And decision trees are supervised models that can either perform regression or classification. And K-means clustering is our first example of an unsupervised machine learning model. And remember, this means that we are not making predictions. We are trying instead to extract structure from seemingly unstructured data in clustering. Right? So clustering is a family of unsupervised machine learning models that attempts to group data points into clusters with centroids. Yeah, hope all of you are aware of this. So these are some of the basic classification models. And coming to best teaching learning practices in machine learning, we start with data collection through simulation, right? Yeah. So, data collection. I mentioned, I already spoke about data collection through, it could be through simulation or algorithms or publicly available domains or self-collected live data, anything. And next step is the data pre-processing, where random sample is selected, normalization of features is done, class balancing is done, visualization of data is done to find whether it is a normal distribution. Yeah, distribution also plays an important role, right? So these are the steps to be followed. Firstly, data collection, then data pre-processing, then choice of the model. You can choose supervised learning, unsupervised learning, semi-supervised learning, regression, classification. And let me tell you, there is no particular learning approach that best suits any particular data set. So for a particular data set, you cannot say this learning model is the best. It depends. Or generally you cannot say supervised learning is better than unsupervised, or and so on. Okay, so there is no general learning models available for different data sets. So it differs for different kinds of data sets. You need to experiment and then choose the model, learning model, right? So the choice of machine learning model is based on uh, say simplicity, okay, interpretability, and training of the model using training set or testing set or cross validation, test accuracy, desired accuracy. And to improve the machine learning model, we get more data, right? Use regularization, okay, and make model more complex, switch to another algorithm, add new influential features. So we need to play around, validate the model, build the architecture, training, testing, verification, a lot of things, right? So we need to perform all these too. So the students have to be taught to not just pounce on some particular learning algorithm or some particular classification algorithm on some particular data set. They have to be taught to experiment this way, right? Train the model to minimize errors. Firstly, the model is trained to minimize errors. That's very important. And learning through knowledge extraction for decision making, adjusting the parameters, hyperparametric tuning, right? Evaluation of the model, predictions. All these are very important. So that's how it has to be taught. The steps have to be taught to students, the steps they need to follow. Okay, they have to work, they have to research on each area, each step of these, and then start working on machine learning or development of machine learning models. Right? And there are certain requisites a student should possess before he learns or he implements machine learning. So, firstly, you need to observe the students and discover whether they are armed with these prerequisites. Okay, whether they know the basics of computer science, essentially programming and algorithms. Right? Not all students will have deep knowledge about programming algorithms. Right. So if they don't possess, we have to tell them to learn them, or we have to ask them to practice, right? And secondly, identify the mathematical and statistical skills. And again, we cannot find adequate skills in students, especially we cannot find mathematical skills in students. Again, they have to strengthen this. We have to emphasize on these things, and we have to make them understand the importance of these areas. Okay, finally, we need to figure out the domain knowledge in different application areas, which you can hardly find in any, right? Domain knowledge is really difficult. Like they are students, they are just UG students or PG students. They wouldn't have had domain knowledge to have all these prerequisites. They need to do some research, right? They need to do some detailed study on these. It's not difficult. They have to work a bit hard to procure these prerequisites. And parallelly, even teachers need to have some prerequisites. Okay, before that, we cannot expect any an undergraduate student to possess all these skills. So when we have such students and who do not have prerequisites, then how do we teach machine learning to them? Right, when they do not possess these prerequisites, how do we teach learning machine learning? So why they would have chosen this subject is the current buzzword is AI or machine learning, which is motivating students to study machine learning. And students generally will be enthusiastic and would have a lot of expectations from teachers, right? In such situations, students have lack of conceptions, filled with misconceptions about machine learning, right? They think that machine learning, they think that machine learning means machine will do everything for them. So we have to remove these misconceptions about machine learning. It's necessary to discover pedagogical content knowledge. Okay, teachers have to discover these pedagogical knowledge, content knowledge. So this is necessary for teachers teaching concepts in machine learning. And this pedagogical content knowledge, a teacher must have knowledge about pedagogical content knowledge to teach a particular subject matter, right? This is nothing but a special combination of content and pedagogy that's uniquely constructed by teachers. Okay, it's a special form of an educator's professional knowing and understanding, we can say, right? So this pedagogical content knowledge also is also known as craft knowledge. It comprises of integrated knowledge representing a teacher's accumulated knowledge wisdom with respect to their teaching practice, including, say, pedagogy, students, subject matter, and the curriculum, right? So, pedagogical content knowledge must be addressed within the context of diverse pedagogy. So, this is a useful representation for concepts in machine learning where analogies, examples, and explanations can be effectively delivered, right? So teachers have to understand this. Please explore on pedagogical content knowledge and understand, so that you can represent, or you can understand how you need to deliver, or understand the analogies, examples, explanations, how they can be effectively delivered to students. So these are the teachers prerequisites. Okay. Yeah, and conceptions. I spoke about conceptions. These are the common mistakes the learners make when applying machine learning. Yeah, teachers have to come up with some methods to informally assess the students' knowledge of machine learning concepts. Right? Say, lack of conception, right? Uh, Preconception, misconception. What distinguishes students is their lack of understanding rather than misunderstanding. Okay, so students' preconception is more based on the reputation of machine learning rather than how machine learning actually works, right? So students are usually familiar with the term machine learning through their peers, friends, say social media, and they have a misconception about machine learning. They think machine learning is a concept where computers have the capability of decision making on its own, like humans, right? And this, when they enter into this degree, or when they start learning machine learning, the reputation of what they have about machine learning can intimidate the students or make them over optimistic also about the abilities of machine learning, right? So to overcome these conceptions, we have to try and simplify the concepts by asking them to understand simpler machine learning algorithms. Initially, start with simpler machine learning algorithms that do not require a higher level of prerequisite knowledge, and then ask them to describe, trace, interpret, identify the algorithms. Okay? Perhaps we can start with simpler algorithms that can be visualized, like k nearest neighbor, decision tree, and so on. This could be the preliminary step. Okay, and as a next step later, abstract techniques could be introduced, namely support vector machine, reinforcement learning, neural networks, which are relatively complex to visualize and interpret. Or in other words, we can say that they require prerequisites to work with, right? So initially, we can start with simpler algorithms and then introduce the complex techniques. And an advanced step could be asking them to develop a model using steps for model development, including data collection, preparation, data pre-processing, implementation of a machine learning algorithm, training and testing split ratio, validation, performance evaluation, all these, right? So, take the focus away from the inner working of the algorithm, right? And focus on teaching its applications also. And libraries, especially, can be difficult for students. Okay, even if they are trained in coding, libraries could be difficult for students to understand. And they also need to understand the code documentation, right? How to document these. They implement, and how do they document? They have to be taught to document. And they also have to understand how to connect the available functions and their respective arguments with concepts learned in lecture. So there are many library now we use Python for machine learning implementation, right? And there are many library routines available in Python related to machine learning. So they need to connect the available functions and also connect their respective arguments with concepts learned during the lecture hours. Such knowledge should be taught by faculty to help the students succeed on, say, their assignments or projects they take up, right? So, every student, as I mentioned, cannot grasp in a similar way. Some students could be fast learners and some slow. isn't it? We come across such students. In that case, if the student fails to understand or he fails to communicate or fails to grasp or to develop a model, then students need to have prior knowledge on at least function arguments, what it returns, okay, and also the library routines available. If they're aware of all these, they can work. And if they do not have to develop new algorithms, but understand how to use the, if they cannot develop their own, if they cannot implement from scratch, then they have to understand how to use the black box. At least you have a more algorithm, right? Even library routines are available for each technique, machine learning technique. So they need to know at least what input to give and what output to expect. Yeah, and we can ask them to take a simple data set, implement simple steps, and eventually implement the complete algorithm once they get a hang of it. So this is how we can deal with slow learners while teaching machine learning. Okay. And as I said, libraries could be difficult for students, even if they're trained in coding. So they need to understand firstly, they need to understand the core documentation, and we can help them to connect available functions and their respective arguments. Yeah. And this will help them in completing their assignments. So as a next stage, teach them the integrating aspects integration of aspects into a system. How to integrate all these developed modules into a system. Okay, students find it harder to achieve their relational learning goals, and these involve a student combining the skills to build and tune a model. Um, so we have to teach them to make design decisions about features, parameters, and we have to teach them how to involve or how to combine the skills to build and tune a model. Right? And to make the students achieve their learning goals, relate real life to computer input output. Okay, and apply evaluation to tune parameters to improve performance. Okay. So, computer IO can be related to real life by discussing about the creation of features involving, say, combining data cleaning skills, domain knowledge of the problem, understanding of how machine learning models are affected by the quality of features, right? Envisioning the possible features of the model. And it also involves identifying how to operationalize the real world phenomenon into a format valid for computer input, right? For example, say uh, we may have to transform images into numerical values, right? When we have images, how to quantify or how to transform into numerical values, or raw text. When we have a raw text, how to transform to n-grams or word vectors, right? Those have to be taught. And finally, they have to be taught to apply evaluation to tune parameters, right? To improve performance and optimize performance, represent a model on different parameters after evaluation. And while optimizing parameters, we have to decide when to stop optimizing. Right? Most of the students would be expecting the model to optimize automatically with no or less human intervention. They have to be taught to optimize parameters. Okay, and also combat the effects of overfitting and underfitting, compare and contrast algorithm parameters and output. And we need to explaining an output is a difficult task, isn't it? For example, comparing and contrasting performance on different regularization terms is a difficult concept for students. So if they lack the prerequisites to understand parameters, then it's difficult to understand how tuning works, right? Most students are clueless during practice sessions about what an output means for the problem they're trying to solve, whether performance is an output or classification is an output. And they have to be taught to interpret the output based on the problem statement. Okay, and feature selection, they have to be taught the importance of feature selection, which otherwise affects the performance of the model, right? And apply evaluation. According to my experience, applying evaluation is the most difficult task to teach because, again, it involves human decision or intervention. Students believe that they do not have to do much work after implementation because they have the misconception that computer and machine learning will figure out the rest, right? So this applying evaluation is very difficult to teach, and we have to figure out a way to teach them, make them understand. Okay. So practice sessions, what we call practicals or tutorials in some of the institutions. So give students open-ended problems, which would involve developing a new model from scratch, say for assignments, for class activities, final projects. We can give open-ended problems. And open-ended problems require constructing a new model, right? Establishing requirements for the problem, employing all the skill learned in the previous stages, and then communicating the results of the model and also communicating the limitations, isn't it? So the difficult aspect is getting students to grasp that the design decision of a model should be dictated by the problem they are trying to solve, rather than machine learning being one size fits all, right? This task is difficult because the amount of algorithms can overwhelm students when deciding which one to use, right? So according to my observation, there are many ways to analyze a model's performance, which make articulating it difficult. Okay, students take a data set, implement things, but have difficulty in communicating and reflecting on what it means. An analysis of performance includes describing the limits of a model and how it can be used, right? And here students struggle with the design, evaluation, and communication of the engineering process. Okay, a model will only be as good as your data. So if you have a good data set, your model will be good. They have to be taught about that. It's difficult to students. It's not everybody's cup of tea to communicate well. So it's difficult for students to communicate the results while using concrete, relevant technical terms. When they have to present it using technical terms, it's difficult for us and for students too. So when we need to try, what we need to try is emphasize on the point that a model will only be as good as your data. Okay. Then, yeah. So academic activity-based teaching or content delivery involves, yeah, we have even in the morning session, the second session, we were introduced to these concepts. Say lectures refers to the lecture sessions through classroom contact sessions, and tutorial refers to sessions consisting of participatory discussions, self-study, desk work, quiz, seminar presentations by students, along with other novel methods that enable a student to efficiently and effectively absorb and assimilate the contents delivered in the lecture session, right? And practice sessions or practical sessions um, refer to practical sessions, and it consists of hands-on experience or laboratory experiments or field studies, case studies, say minor major projects that equip the students to acquire the much required skill component. So in terms of credits, every 1 hour session of lecture amounts to 1 credit per semester, and a minimum of 2 hour session of tutorials or practice sessions amount to 1 credit per semester. That's what we follow in our institution. So coming to assessment, the evaluation of students should be spread over the entire semester on the various constituent components of the course. So continuous assessment takes into account all academic activities undertaken by the student during the currency of the said academic semester. Okay. And it entails activities ensuring continuous assessment, such as, say, conduction of review tests, quizzes, tutorials, assignments, practicals, surprise tests, project work, term work, seminars, discussions, and so on. Right? So, yeah, I took this from Dr. Vijendra Singh's, Professor Vijendra Singh's discussion during the second session. So he explained about these, right? About the weightage given for formative assessment and summative assessment. Let me not go to that. Fine. So project assessment. Yeah, again, here we have to give equal weightage for in semester and semester end assessment. So in semester assessment is given 50% weightage, and under that we have assignments and mini projects with 20%, which are open books basically. And mini projects, students work on different domains, and domain experts from industries may also be involved. And those are open book assessments, which can be awarded 20% of this, 50% in semester assessment, and three tests are usually conducted, which are closed book tests. Okay, or generally we give questions and the answer. So three tests are conducted, and 30% will be taken from these closed book tests and 20% from the open book test. That becomes the in semester assessment. And semester end assessment or semester end examination we conduct, and 50% of it will be considered for their final marks, or final assessment. And we have two parts. Usually we follow this pattern where we have two parts in a question paper. First part consists of 5 compulsory questions for 10 marks from each unit. So our syllabus is divided into 5 units. It could be 5 or any number, but we make sure that each the questions include from each unit of the syllabus. Okay, and part B consists of 10 questions with internal choices from each unit. And questions are framed based on the cognitive levels. Again, Bloom's taxonomy and course outcomes. All these Professor T. N. Nagbhushan discussed, right? And project assessment components. So a project must be treated as a special course to be evaluated through components like assessment on problem definition, problem identification, firstly, and definition, and literature survey defending methodology to be adopted for the projects, and assessment on conduct of the experiment or software designing, developing and implementation, preparation of a draft report including results, discussions, and so on, and assessment in two parts based upon final presentation and demonstration or defense. And evaluation comprises of the project report evaluation and final presentation also. And assessment comprises of demonstration and defense. Okay. So this is how a project is assessed. Again, you can have a percentage weightage for these evaluation. Usually we have many phases of project evaluation. So in each phase, we consider each of these factors and assess them. Okay, and continuous about continuous assessment of projects. So yeah, we have C1, C2, C3. Again, Mr. Rajendra Singh explained during his lecture. So this is how it is evaluated. Well, about attendance, again, he mentioned. So compelling students to attend makes no sense, isn't it? Unless they attend with their own interest to gain knowledge. So teachers have to understand the students' requirements and prepare to classes so as to draw their attention, as explained by Professor Satish Singh on the second day. Right? We need to draw their attention so that they don't miss classes and we don't have to impose. So about 85% attendance is mandatory to complete the course in our institute. But we cannot compel students. So students should not be forced for attendance, but they themselves have to participate in all the academic activities, not only to successfully pass a course, but to gain knowledge. And our academic system always takes care of it, right? In every institution, the academic system takes care of it. So this was discussed by Mr. Satish Singh. And finally, students do not get stuck on individual concepts, but on the to conclude, let me conclude by saying that students do not get stuck on individual concepts, but on the development and evaluation of models and communicating the engineering decisions, right? So learning goals should transition from task-specific skills to combining skills to build a model to finally applying skills to solve a problem. So faculty, by considering student development, faculty can set and define appropriate learning outcomes for lectures, assignments, and assessments. and all academic activities undertaken by the student during the current academic semester should be included during assessment, right? So I conclude my discussion, but before that, I want to show a case study. So let's just check a case study. This is on development of machine learning models for medical informatics, which I have worked on. And and I've already, yeah, we're coming to biomedical informatics. Let's understand why artificial intelligence model development is essential, especially in bioinformatics, biomedical informatics. So, as all of us know, why it is required, advances in AI or machine learning, faster processors, and the availability of digitized data have contributed to a growing number of researchers describing machine learning applications in biomedical informatics. So, importantly, however, developing, validating, and implementing machine learning models for healthcare and genomics entails some particular considerations to increase the chances of eventually improving patient care in health informatics and to solve key problems in genomic medicine and bioinformatics, right? So the first step in developing machine learning model for healthcare is problem selection. Let me take the example of healthcare. I've worked on genomics also, but let me take the example of healthcare. So the first step is problem selection and defining the prediction task. Successful machine learning models should be expected to make a meaningful impact in patient care by providing actionable insights, isn't it? For example, a machine learning model can be used to predict factors that are used in clinical treatment guidelines. A subtle but critical point is that machine learning models should only leverage input data that are available at the time when the proposed clinical decision is being made, right? And one key consideration in problem selection is data availability. Sufficient data are required to both develop a performant machine learning model and evaluate the model with high confidence that the results will generalize. For example, training a performant convolutional neural network to diagnose diabetic retinopathy from fundus images may require tens of thousands of images, right? An evaluation will require at least 1,000 more, right? So data may be limited by the lack of digitization, such as in pathology, where most slides are not scanned, right? Or say inaccessible, the data could be inaccessible because of patient privacy or commercial concerns, or lacking because the disease of interest is too rare. Yeah. So the surmountability of each of these issues varies on a case by case basis. But in general, data availability presents challenges to the application of machine learning to healthcare. So, a reasonable approach may be to select problems at the intersection of useful applications and available data, not just, yeah, students again do this mistake. Many of them come to me saying that they'll work on cancer detection or heart attack prediction. So the data set is not available due to many issues or many considerations or like ethical issues. The data sets are not available, but they come up with the model also. They come up with the approaches to be used also, but they have to select problems where applications and data intersect, right? Fine. So again, the next step is after problem selection is dataset construction. Okay, so yeah, this is about curating dataset. Uh, Fine. So the next step, because data mining, dataset naming can vary. Yeah, dataset naming can vary between studies. For better consistencies with the clinical literature, we'll use development set to refer to the dataset used for developing the machine learning model, and validation set to refer to the dataset used for final assessment of machine learning model performance. Okay. So again, this development set is further split into a training set, which is used to update model parameters, and a tuning set, which is used to select model hyperparameters. So in the machine learning literature, The validation set is frequently referred to as the test set or holdout set, they say. Well, tuning set is called the validation set in clinical setup. Okay, fine. Um, so often the prediction task will exhibit skew in the different categories.
Ma'am, you are on mute.
Oh, I don't know how it's auto muted. Fine. Let me continue. I'm sorry for that. So I was speaking about class imbalance. Uh, s- okay, so we need to ensure that the minority class is well represented. Okay, ensuring that minority class is well represented is also important because of the diversity of data that will be seen in real world use. Okay, for example, based on data, patient demographics and disease subtypes. Okay, although there are techniques to minimize this effect of class imbalance for training machine learning models, a better solution may be to augment the data set with more examples of minority class. Okay, this augmentation may require additional steps to ensure proper model calibration or adjustment in the evaluation metric, right? Then the process of model development for eventual implementation has several main considerations that influence model architecture design. Okay, data modality and volume, model interpretability, model inference time, right? Balancing model overfitting and underfitting. There's a wide range of data modalities exists in healthcare, such as 2D images, 3D volumes, waveforms, laboratory measurements, text, and so on, right? So, with each model type, the complexity of the model should be appropriate given the data size. Okay, for example, a 100-layer network may overfit a classification model trained using a data set of only 100 images. Yeah. So, these are the main considerations which influence the model architecture design. And decomposing the model into multiple stages can have important benefits. So, first, the intermediate output may be useful. Okay, for example, a segmentation model for tumors on pathology slides can aid review by highlighting suspicious regions, even though the evaluation metric focuses on the ability to classify slides as tumor containing or not, right? And second, health data can differ substantially across data sources because of factors such as institution specific protocols and different imaging hardware. So, splitting a disease diagnosis step into segmentation and measurement may enable easier generalization to new imaging hardware by retraining only the segmentation model, which is more data efficient, right? And last, the intermediate outputs may significantly enhance the interpretability of the prediction. For example, is automated in automated cardiac measurements using ultrasound, predicting the two XY coordinates that comprise the measurement line may be more helpful than the final measurement, isn't it? So, on the other hand, the use of multiple stages can incur significant complexity in software implementation and model maintenance and improvements. Hence, the decision of whether to do end-to-end learning for healthcare applications will depend on factors such as data set size and whether the intermediate outputs are of any value, right? So the process of selecting a model architecture and training the model essentially involves balancing model underfitting and model overfitting. Right? I don't want to explain this. Yeah, as all of you know, model underfitting occurs when a low capacity model is used relative to the problem complexity and data size, which can be handled by selecting a more parameter rich model or weaker regularization during training. Whereas model overfitting is more concerning because evaluation overestimates the generalization performance on previously unseen data. Okay, and here it can be prevented by the use of tuning set within the development set for out of sample estimates of performance and multiple regularization techniques. Right, and finally, while developing a model, the train tune validation split must be carefully preserved. Okay, the validation set results should not be used for any decisions such as model architecture selection, training checkpoint selection, or other hyperparameter optimization. What it means is, in other words, training and tuning should only be done within the development set. Okay, because the recent models tend to be high capacity deep neural networks that can memorize entire training data sets with random labels. And tuning can have a large impact on the final performance. Any violation of development validation hygiene can result in ungeneralizable performance. So, crucially, evaluating the performance of multiple model configurations on the validation set can result in unintended tuning using the validation set. Okay, so evaluation metrics have to be consistent. Okay, and the two main categories of evaluation metrics measure discrimination and calibration. And we have discrimination metrics measure the ability to correctly rank or distinguish two classes, for which we can use AUC, area under curve, or C statistic. And calibration evaluates how well the predicted probabilities match the actual probability. Right? So there are many challenges. Yeah, I don't want to discuss about. Yeah, there are many challenges which students also should know, that no machine learning model will be 100% accurate in real world scenario. Okay, the students have to understand that, and we have to teach them or tell them that no model will be 100% accurate. And there are many legal and regulatory issues and also implementation challenges, and they have to be tackled by them. And model needs to be implemented. They have to be used in both retrospective and prospective studies. Okay, and under reliance and over, there could be under reliance of the model, and there could be over reliance also. Right, the user might rely more in health related model development. We cannot over rely on the results. Right, they finally rely on their lab. Or they test lab tests or the scanning or whatever they do, right? Even under reliance is a challenge. So finally, the process of implementing these can be complicated because of these process issues and access issues, but implementers need to consider the integration of new models into the workflow. They have to keep on trying with new models, not just fix that you use some metacognitive neural network and use some algorithm for optimization and the model is built. No. So the implementers or the students have to consider the integration of new models into this workflow. And also privacy, ethical, legal, regulatory frameworks, all these are locale specific, right? And they'll need to be worked through for final approval and usage in real clinical workflows. So they have to understand that also. It's not that your model performs well and that is the final model. No, you have to get an approval. Real clinical work, they have to be used in real clinical workflows, and you need to get final approval by the concerned clinician. So this is my research work on development of AI models in medical informatics, where I've developed a machine learning model for early detection of depression using minor cohort. Okay, and the model is built using boosted feature selection and metacognitive neural network with projection-based learning method using particle swarm optimization algorithm optimization. So detection of depression is done using these techniques. Okay, this is the model. Okay, this is the model developed. So students should be encouraged to identify or come up with this model. Okay, where it starts right from the data acquisition, then assessment of patients, and then pre-processing. Under pre-processing, we handle continuous data, eliminate redundant data, handle missing data. and that preprocessed data is fed into feature selection using XGBoost, and then classification of depression is done using metacognitive neural network and projection-based learning. And then particle form optimization is done for hyperparametric tuning to optimize the parameters of the metacognitive neural network or the classifier essentially. And finally, result analysis is done. Okay, so this is the implemented implementation screenshot, where we input the training set, and we get the overall testing efficiency of around 77%. And after optimization, once it's optimized using PSO, the variables we can see here, these are the parameters of the classifier which are optimized. Once it's optimized, these are the optimized values, and after that you can check the testing accuracy is 94%. So the importance of optimization, importance of hyperparametric tuning, importance of feature selection, importance of parameters, importance of data set, everything has to be taught and they have to be carefully taken care of, right? So these are the references. And I've taken a few from the internet also, internet sources also. So it is open for queries. And what I would like to say is students can be encouraged to start model development from scratch to understand machine learning better, right? So I'll stop at this point. And if anybody has any queries, I can take queries.
Thank you, madam. Thank you, Dr. Vanishri, ma'am. You have given really very nice lecture, and you have kept us engaged for almost 2 hours, right? Approximately 2 hours.
Yes.
You have touched upon major concepts of the machine learning, at least from the outer end, right? And also you have given some case study of your own research work, which you carried out, and you designed the machine learning. I think this will be very, very useful, that it should not only be the theory, but it should also be complemented with the practical things. So that will really make whatever the explanation you give in the class, that will make really meaningful. So which is very nicely brought out by Dr. Vanishri, madam. I think there are some questions, madam, here.
Yes.
So, Anita Shah is asking that, ma'am, what are the difference between machine learning and data science? Both are same or different? She's asking.
Actually, we use in the same context. We use a data science as a synonym to machine learning, but basic concept is the same. And data science might involve machine learning involves more of, as I mentioned, model development and all those. So data science involves everything: mathematics, programming, and domain as well.
Yes, true. So so just to make Anita Shah very clear, actually, data science is a bigger umbrella than machine. Machine learning is small part of
comes under data science.
Okay, so I think this is, and there is another question, ma'am. There, what is the difference? Ganesh Pai, I think Ganesh Pai from PA College.
Right.
What is the difference between organized and structured?
Actually,
in what context, Ganesh Pai, would you please tell this one?
Sir, it was mentioned that the data set should be first initially organized, and another point it was told it was structured. So whether it is same or whether it is different.
No, actually, we use we use organized and structured as synonyms, but no, organization is different. Organizing data, say you have, for example, you have an EHR, okay, electronic health record. So my area of my interest is in detection of or classification of only diabetes. So I organize that data, or I organize that data in such a way that the parameters which I am interested in, those will be present. Structured is like you have structured data will be in terms of rows and columns, right? Organized data means you organize or you put them in a proper format, or you collect data which are relevant to your work. Structured is you convert that data into a tabular form, in simple words, in a table form with rows and columns.
Okay, madam.
Yeah.
Okay. So, ma'am, there is one more question from Anita Shah only. Madam, I have little bit knowledge about mathematics, but I am good in programming. Can I do machine learning programming? Madam is asking.
Of course, Miss Anita, you can do machine learning program, but you need to have why you need to understand math behind machine learning is you need to understand how to analyze it, and the algorithm, like everything is like what the algorithm involves mathematical concepts there. Even Naive Bayes theorem is used there. So to understand how it works, you need mathematics. You need to know mathematics behind machine learning, and it's not so difficult for you to learn math. You can definitely explore on math and then start. If you're good in programming, you can definitely learn machine learning also.
Yes, there is last question here. Where to find the data set which is easily available for students?
Okay,
So
there are many. I can share the resources. I have a long list of dataset resources. So one of them is UCI Machine Learning Repository, which has extensive datasets available in them. There's Kaggle. There are many more. I can post you the list, Ms. Samir Fatima.
Yes, so if any more questions, you can just unmute yourself and then ask if you have any queries.
Yeah, if you have any queries, you can post them.
Yeah, you can. Yeah, madam will be available for another 2 days. I think you can ask her anytime.
Anytime, exactly. Yes.
Yeah, there is no issue. So overall, madam, it was very nice to means you have summarized the machine learning things, and also you have demonstrated it that how the theoretical concepts can be put into practice.
Thank you so
And,
much.
yeah.
I thank all the participants for patient listening. I dragged.
Yes. Yeah, usually afternoon session is very difficult.
Yes,
So you are
exactly.
having a lot of patience in sitting and listening. That's really
True.
wonderful.
True. Yeah. Thank you so much.
Thank you one and all. Thank you, ma'am. Thank you.
Thank you, Javed.
So
Thank you.
tomorrow we shall meet at 9 o'clock, 9 a.m.
Yes.
And we have very eminent speaker, Dr.
Darshan Iyengar.
Yeah, Dr. Sudarshan Iyengar. So he's from IIT Indore, no, madam?
Roper.
IIT Roper. Sorry, IIT Roper. So he would be taking you into some different aspect. So this, see, one thing which I observed here was very interesting that, see, SJC was previously under BTU and it became autonomous. And we have the best practices from IIIT Allahabad and also best practices. Tomorrow we are going to listen from IITs. So I think this would be a very nice combination that those who are attending, I think they would really get the flavor of different ideas.
Exactly. Yes.
Thank you.
I request all of you not to miss any sessions. Yeah, we shall meet tomorrow at 9 o'clock. Thank you very much. Thank you, Javed.